So before I move on to the next lesson, I want to talk about the equation of a sphere. Because spheres are going to come up a lot in this class. And it's going to be important that if you've never seen the equation for a sphere, it's important that you know what the equation of a sphere looks like before we keep moving on through the class. So the equation for a sphere, so I'm going to say the equation of a sphere that has a center C at point HKL and radius R. And it's the following equation. And I'm going to be fancy in color code. HKL radius R is, and it's going to be a bunch of things in parentheses squared. Well, R squared is going to be at the end. The radius squared is going to be equal to, and again, you're going to notice, you might notice a little bit of a similarity as I write this out. So it's going to be x minus h squared plus y minus k squared plus z minus l squared. And you might be noticing, wait a second, what's going on? I should probably write my l's like that so you don't confuse them with ones. You might be noticing what this looks familiar to. And if you said the equation of a circle, you wouldn't be completely wrong. The equation of a sphere is very similar to the equation of a circle. Again, we're just adding in that third dimensional component here. Now, it's possible that you might be asked to, on a homework question or on an exam question, figure out what the equation of a sphere is based on certain facts. So we could say show that we've got this equation here. So we've got this big, long, nasty equation here. And we want to show that this is, the equation of a sphere. And this might not jump out to you immediately what to do, but if I group the terms like so x squared plus 4x plus y squared, if I choose to group my terms like this, minus 6y plus z squared plus z squared plus 2z, I'm stupid, plus 6 is equal to 0. Now you might notice here that, well, especially if I maybe subtract the 6 to the other side. And if you're confused as to what I did, I just subtracted 6 from both sides. But you might be noticing here, well, we know that we need to get the equation into a form where it's x minus h squared plus y minus k squared plus z minus l squared is equal to r squared. Well, we could do this by completing the square, by grouping terms and completing the square. We'll be able to do that. And so let's go ahead and try and complete the square. So we're going to have x squared plus 4x plus something plus y squared minus 6y plus something plus z squared plus 2z. So we want to finish completing the square here, and the way we figure out how to complete the square and how we figure out what goes into these blanks is we take the middle term. So we take the middle term, we divide it by 2, and we square it. So in this case, we have 4 what's going to go here is 4 divided by 2 quantity squared. And what that's going to end up being is that's also going to end up being 4. But of course, whatever we do on one side, we're going to want to subtract on the same. We're either going to want to subtract on the same side, which you're kind of used to, or what we add to one side, we have to add to the other side. And that's what I'm going to choose to do here. So I'm going to choose to add it to the other side. And of course, you could have done -4 and then added the 4 over here. But I'm just going to choose to add it straight to the other side. We're going to do that again. We're going to do -6 divided by 2 quantity squared, which is going to be -3 squared, which is going to be +9. So 9 is going to go here. We're going to add 9 on the right side because we want to, of course, want to keep this equation balanced. And 2 divided by 2, quantity squared, that's 1. We're going to have a 1 here, and we're going to add 1 to this side. And what we're going to get is we notice that now we have perfect squared trinomials, so we can factor out to get a perfect, perfect squared trinomial. So we're going to get x plus 2 squared, we're going to get y minus 3 squared, and we're going to get z plus 1 squared. And that's equal to, well, 4 and 9 is 13, 13 and 1 is 14, 14 minus 6 is 8. And so we get that the equation of the sphere is x plus 2 quantity squared plus y minus 3 quantity squared plus z plus 1 quantity squared equals 8. And just to check, or just confirm, our center is the point -2, 3, -1. And our radius is the square root of 8. Because remember from our equation, this quantity is radius squared. It is not just the radius. We have to take the square root in order to get the radius. And just like with quadratics and that kind of thing, remember it's not just whatever sign is here; it's the opposite. Because the equation, remember our equation up here, we're subtracting. So if h is positive, then this will be subtraction. If h is negative, then subtracting negative is the same thing as adding. So that's why we have negatives here and here. So I just wanted to make sure that we knew how to write the equations of spheres and that kind of thing before we move on to more complicated things, because it's going to be important that we can write the equations of spheres, because spheres are going to come up a lot in multivariable calculus.